Welcome! In this video, you'll use the embedded C creator from TI Electronics to build a sequence control example. We're going to create a simple state machine. You can follow along with the diagram shown here. This system has 4 states. State 0 is the initial state. All 3 LEDs are off. The system waits for a momentary button press. The button is connected to GPIO 21 and labelled test switch in the diagram. When test switch is pressed, the system transitions to state 1. In state 1, LED 1, GPIO 23, labelled test LED 1, turns on. After 12 seconds, it moves to state 2, where LED 2, GPIO 33, test LED 2, turns on and the others turn off. After 13 seconds, it transitions to state 3, where LED 3, GPIO 37, test LED 3, turns on. After 14 seconds, the system returns to state 0 and waits for the next button press. Here's the schematic. We're using the same breadboard setup from the previous LED blink video. The wiring is shown here. You can reuse the Simulink model and CCS project from the LED blink example, or start from scratch if you prefer. Plug in the dual masters via USB. Open the previous Simulink model test, blinkt.slx, then save it as sectoral ti.slx. Next, open example 15_statemachine.slx from the Embedded C Creators Examples folder. Drag the state machine components from example 15_statemachine.slx into your new model SEQCTRL_TI.slx. Then close the example file. We use a switch case block to define the next state. Each state's behavior and transition condition is inside a case action block. There are 4 states arranged top to bottom. This layout is similar to a PLC ladder diagram, but with one key difference. A PLC scans all rows every cycle, but here, only one state runs at a time. We also use a visibility feature to highlight the active state in green. Double-click the Case 0 action block to open the State 0 subsystem. Rename the DIN block from RB7 to Test Switch. Double-click it and update the parameters. From the schematic, we know the input is 0 when the button is pressed, so in the switch block, set the top input to 0 and the bottom to 1. This keeps the system in state 0 when the button is not pressed, and moves to state 1 when it is. Now rename the D-out blocks. RB12, Test LED1. Set GPIO 23. Constant equals 1 LED off. RB13, test LED 2. Set GPIO 33. Constant equals 1, LED off. RA4 test LED 3. Set GPIO 37. Constant equals 1, LED off. Open case 1 action. Rename D out from RB12 to test LED1. Set GPIO 23. Constant equals 0, LED on. Double-click the M wait block and keep the wait time at 12 seconds. Since the output on is 0 while waiting, set the switch block. Bottom input equals 1, stay in state 1. Top input equals 2, go to state 2 when time is up. Open case 2 action. Set and wait to 13 seconds. Switch block inputs. Bottom equals 2, stay in state 2. Top equals 3, go to state 3. Update doubt blocks. Test lead 1 arrow, GPIO 23. Constant equals 1, off. Test LED 2. GPIO 33. Constant equals 0 on. Open the default action block, state 3. Set and wait to 14 seconds. Switch block inputs. Bottom equals 3, stay in state 3. Top equals 0, return to state 0. Drag in a display block. And connect it to the SEC output of EM wait. No need for a probe block because the arrow in the name means it's already probed. Update D out blocks. Test LED 2. GPIO 33. Constant equals 1, LED off. Test LED 3. GPIO 37. Constant equals 0, LED on. Back in the top-level model. Set delay block sample time to 0.01 for faster button response. Rename D out to heartbeat. Set sample time to 0.5. In M Modbus server debug setup, set max QTY for embedded wait block to 3 because we use total 3 M wait blocks. Save the model. Right-click Case 0 action, check the tag. It should be My State. All case action blocks in the same state machine must use the same tag. Check and match tags for Case 1, Case 2, and default action. If they don't match, Simulink will show a build error. Keep Simulink open. We'll switch to CCS next. Open CCS version 20.xx or later. Right-click the previous project empty_driverlib_project, choose Duplicate. Rename the copy to secucutral 4F2800137. Open C2000.sysv. Add GPIO. Test switch. Input floating GPIO21. Add GPIO. Test LED 1. Output open drain. GPIO 23. Initial value equals high, LED off. Add GPIO. Test LED 2, GPIO 33, same config. Add GPIO. Test LED 3, GPIO 37, same config. Build the project. If you see error number 10099-D, program will not fit into memory. It means you're building for RAM. Right-click the project, build configuration, CPU1_FLASH. Then build again. It should succeed. Back in Simulink, click Tools arrow Build Embedded Target and open its IDE. Set base sample time to 0.01. Select the CCS project folder. You'll see a message, Build successful, CCS is running. In CCS, build the project again. If you see an error like expected a field name, it's likely due to a name conflict. Simulink uses test switch as a struct field, but CCS also defines it as a macro. To fix this, rename the GPIO in sysconfig and test switch _CCS, test LED1, test LED1 _CCS, test LED2, test LED2 _CCS, test LED3, test LED3 _CCS. Build again, it should succeed. Check board.h to confirm the new names. Back in Simulink, build again with base sample time 0.01. You'll see the success message. In CCS, build the project one more time. Connect the DSP board via USB, it will power on. Right-click the project, Flash Project. After flashing, LED 5 should blink every half second. Back in Simulink. Unplug the DSP board, wait 2 seconds, then plug it back in. Click Run. You'll see Case 0 action highlighted in green. All LEDs are off. Press the momentary button. Now Case 1 action turns green and LED 1 lights up. After 12 seconds, it switches to Case 2 action, LED 2 turns on. After 13 seconds, it moves to default action, LED 3 turns on. You can also watch the countdown in the display block inside State 3. After 14 seconds, it returns to Case 0 action. Did you notice the heartbeat display block? Even though the LED on the demo board blinks every 0.5 seconds, the display in Simulink might update much more slowly. That's because the state machine runs every 10 milliseconds, and its probes can consume a lot of your PC's CPU time. Meanwhile, the heartbeat block runs every 500 milliseconds, so Simulink may poll it at random intervals. To fix this, double-click the heartbeat doubt block and change its sample time from 0.5 to 0.02 seconds. Then click Run again. Now you'll see the heartbeat display alternate between 0 and 1 almost every 0.5 seconds, just like the actual LED. But keep in mind, this change is only for PC monitoring. Don't use the 0.02 second sample time when generating embedded C code. Otherwise, the LED will blink every 20 milliseconds on the hardware. Thanks for watching.